Hello, I'm Ronald White, and today I'm going to go over an integration that I did between MobileCause and Salesforce. MobileCause is a provider of solutions for nonprofits, chiefly. They make it easy for patrons to donate to causes, and I'm going to be integrated into the Salesforce.com platform. And I'm doing so via callouts directly from Salesforce and the MobileCause API. What we're looking at here is the IntelliJ IDE with the Illuminated Cloud plugin. I highly recommend this if you're not using it. It has made Sublime Text a text editor once again. This integration is done natively 100% in Salesforce. When I say Salesforce.com is a platform, this is really what I'm talking about. I've got 5 classes that I want to cover. The first one here is this MC Transactions Provider. This is actually the class that's responsible for doing the callouts and deserializing the transaction. There's a couple cool things about this. First is up top in the constructor. You can see that I'm pulling back fields from MobileCause _ MDT. This is notation for the custom metadata type within Salesforce. Its benefit over a custom setting is chiefly that I can migrate not only the configuration, the S object, but I can also migrate the data itself. It's not as fast as an application setting because it's not application cache, and you lose some of the methods that come with the custom settings, but again, the data is deployable. So there's a couple methods here we'll go over. The first one is the generate report on server callout. The way this API works is that you have to actually specify that you want to get the transactions. It'll return you an ID. Then you have to actually go and get the transactions with that ID. So it's kind of a two-part process. The first thing we do is generate the report on the server with a date parameter. And the next thing that we need to do is fetch the report from the server using the report ID that was returned. What's really interesting about this is it's actually deserializing it into this public virtual class here. I've seen a lot of different ways to accomplish this. In ETL land, typically I see people use staging tables because you have to take action on this data, and it makes sense to have it rest someplace so you can take appropriate action. But even in the app dev space, I've seen people use a temporary table just to process their transactions. This is actually kind of the best of both worlds, I think. It's available for you in memory, so it's very fast, and you don't have the overhead of maintaining a separate object. And an added benefit of this actually is a single place now where you can maintain the functions that are required to get the data the way you want it to be. So that's what this class is doing. The actions are called from this opportunity generator class. This is doing something similar in the constructor with the custom metadata type, and it's newing up all the members. And as you go down through here, and there's nothing magical, the top level method is actually going to do all the work, but it's calling on these methods below it. The first thing is we actually fetch transactions based on a date in the class I just showed you. This date is dynamic and it's driven off the metadata, so should the requirements change and the date needs to be pulled in or it needs to be kicked out, it's a simple config change, and the client doesn't have to worry about digging in the code. After you get the transactions back, of course you have to process them. And these are person accounts, and that's what this is doing here, is just making sure I'm getting the right ID for the person account. And then I'm actually looping through the transactions. And a transaction in MobileCause is represented by both an account and an opportunity within Salesforce. So what you're seeing here is that I'm looping through the transactions, and I'm adding account records and I'm adding opportunity records to the respective lists. And then I'm actually issuing the upsert commands. And I separated the upserts into 2 separate methods, one for accounts and one for opportunities. The account just needs a list of accounts. And then when we upsert the opportunities, it's a little more complicated because we need a list of opportunities but also a list of accounts. And also too, you have to mate an account to an opportunity. To achieve that, I'm looping through the accounts and I'm adding the MobileCause identifier and the account ID to a map. And then in the corresponding opportunity list, I'm looping through that and I'm actually getting the account ID based on the MobileCause ID in the map. And then of course I'm making sure that I have an account ID and I was able to determine the stage. And if so, I'm going to add that to the list. And then I go through and I upsert the opportunities. I'm keeping track of the IDs that got success, and I'm also going to catch the failures for debug purposes. We're doing all or nothing here. And the last thing I need to do is send a notification. Basically, every time this runs an email sent, it's determining success, failure, warning by the number of opportunities that it detected in MobileCause versus the number of opportunities that it actually were Salesforce ready. Let's take a quick peek at the email class here. Super simple class. It defaults most of the required fields for the email, but it also leaves the option of putting in or passing the parameters as well. And then down here, building it up and sending it. So this is something that could easily be expanded in the future, but for the purposes of this requirement, I just had to work out a way to send an email notification. Two more interesting things about this. First is the scheduler, and then this queuable. So this is the scheduler. It implements schedulable, and this is of course so I can schedule the epics to run hourly, and in this case, or daily, what have you. What's interesting about this though is because the jobs I want to run have callouts, I cannot schedule them. There's a few ways to get around that. First is I can make it batchable, but the batchable code for this really felt like a hack, and truly Bash was designed for batch operations. The other thing you can do is you can annotate @future in your callouts, but the issue with that is @future requires void queuable apex to rescue. What this scheduler is doing is it's enqueuing a job, which is this class here, and what this class is doing is actually calling the generate opportunities, which is in turn making the callouts. So let's take a look at how this might work end to end. I'm not going to go through the trouble of scheduling it. What I'll do here is I'll issue an anonymous statement, and this is again hitting this opportunity generator, which is hitting the transactions provider, which is in turn making our callouts. We'll go ahead and give this guy a run. I get a success back, and you can see that I upserted a single account ID, and the opportunities that I got back from MobileCause matched up to the opportunities that I was able to create within Salesforce. And I should have gotten an email notification. Let's take a quick look. So everything's working great. So there you have it, an end-to-end RESTful integration between two autonomous systems using nothing but Apex sans middleware. Thanks.